Okay, so this question is a value question for data sufficiency, and it's a great example of how we can think big picture and use a little bit of min-max strategy to break down really difficult questions. So imagine what would happen if we made K really small here, okay? What would happen to the area of this shape? So we're focusing on statement one. We're told that the area of the shape is 189. And the question is, are there multiple ways to get an area of 189 square feet? Or is there only one K that exactly makes that area occur? And if we make this shape really small, so if we make K really small, you notice that K makes the entire shape very narrow. And that means that the area of this part of the shape is only about 15, or exactly 15. It's 1 by 15. And the area of this portion of the shape, which has a height of 1 and a width of 14, since we just chopped off 1 from this width here, and this was originally a total width of 15, this becomes a total of 14. And since areas are additive, we get an area of 15 plus 14 is 29. Now, what would happen if we made K very large? We can't make K larger than 15 because then we wouldn't have a real shape, but we can make K 14. And if we make K 14, we get a shape like this, where K is taking up almost this full side. And so K is equal to 14, 14, and this becomes 1 and 1. And then we have sides of 15 and 15 here. And the area of this portion is 14 times 15 because it's 14 wide and 15 tall. And then the area of this portion here is 1 times a height of 14. And this is obviously a lot bigger than 29 because 14 times 15 is a very large number. So 14 times 15, obviously the area changes. And what you notice is as you increase the size of K, the size of the area is increasing as well. So the bigger K gets, the bigger the area gets. And there will only be one exact point at which we get exactly an area of 189 because as K increases, the area is increasing. So we'll hit 189 when K equals something specific, and then we'll blow right by it and have a larger area if we keep increasing K. So that means there's only one specific K related to each area, and that means that there's only one specific K for 189, which means this is sufficient. Statement 2 says the perimeter is 60. Well, look at the two examples we painted before. The perimeter of the first example was 15 plus 15, which is 30, plus 14 plus 14, which is 28, plus 1, which is 2, and that gives us a perimeter of 60. Look at the second situation. We had 15 and 15, which is 30, 1 and 1, which is 2, and then 14 on the inside, and this would also be 14 on the inside for a total of 28, and again, we get a perimeter of 60. So knowing we have a perimeter of 60 doesn't tell me if we have this as our K or this as our K, and so it's insufficient. And actually what you'll find out if you mess around with this shape enough is that no matter what K is, the perimeter will always be 60 if we have this set up over here. So no matter what K is, the perimeter is 60. This actually isn't additional information whatsoever. This, however, was sufficient, which means our answer is answer choice A.